Okay guys, let's discuss quiz complex numbers. Okay, for number 1, give your answer in the form of a plus bi for the given two complex number. So 8 minus 3i times 5 minus 2i. You can multiply this one. Okay. 8 times 5, 40. 8 times negative 2i minus 16i. 3i times 5, negative 15i. Okay, negative 3i times negative 2i. So, positive 6i squared. Simplify. 40 minus 31i plus 6. Okay, you have to remember that I squared is equal to negative 1. So, substitute negative 1. Simplify. 40 minus 6 minus 31i. So, answer is 34 minus 31i. Okay, done for this one. 34 minus 31i. Answer is this first one. Okay, better for number 1. For number 2, determine Z1 times Z2 if given Z1 is equal to 2 plus 5i, Z2 is equal to 3 minus 2i. First thing, write Z1 times Z2. Substitute 2 plus 5i times 3 minus 2i. And expand. 2 times 3, 6. 2 times negative 2i minus 4i. I try to take different. Okay. 5i times 3 plus 15i. 5i times negative 2i minus 10i. Okay. Then simplify. 6 negative 4i plus 15i positive 11i minus 10. Substitute. Okay. I squared is equal to negative 1. Always remember that I squared is equal to negative 1. Substitute negative 1 here. Then simplify. Simplify 6 plus 10 plus 11i. So answer is 16 plus 11i. So 16 plus 11i. This is the answer for number 2. Okay, continue for number 3. Okay, refer to the above image. This one image. What is the conjugate of the denominator? This is denominator. 1 plus 5i. The conjugate is 1 minus 5i. Okay, always on the imaginary part you have to find the opposite sign. So answer is 1 minus 5i. Okay. Number 4. Okay. If find Z1 over Z2 if Z1 is equal to 2 plus 5i, Z2 is equal to 4 minus i. So you have to divide between Z1 and Z2. Okay, first thing you need to times conjugate for denominator. The conjugate is 4 plus i over 4 plus i over. So if you cancel, you get 1. Okay, don't write like this. Okay, 4 plus i, 4 plus i. This is the wrong concept. It's given meaning nothing. Okay, mean nothing. So you cannot use. You have to divide between the above 4 plus I over 4 plus I. Okay. And okay, if you want to rewrite, just rewrite. Okay, rewrite this part. So that you can multiply. So 4 minus I, 4 plus I. Okay, the next step. Okay, times 2 times 4, 8. 2 times I plus 2I. 5I times 4 plus 20I. 5I times I plus 5I squared. Over. Okay, 4 times 4, 16. Okay, 4I minus 4I, this one is equal to 0. Okay, minus I squared or plus 1. Plus 1. Why? Because of I squared is equal to negative 1. You can substitute all. That's right, 16 plus 1. Okay, simplify. 8 plus 22I plus 5. Okay, 16 minus, okay, substitute. Okay, I squared is equal to negative 1. Negative 1. Okay, simplify. Okay, 8 minus 5, 3 plus 22I over 17. Okay, your answer supposed to be separated between real part and imaginary part. So 3 over 17 plus 22 over 17I. Check the option. 3 over 17 plus 22 over 17I. So answer is this part. Okay, this part. Settle. Number 5. Multiply these two complex number. Okay, I rewrite. Okay, negative 3 minus 5I times 2 minus 6I. Okay, negative 3 times 2, negative 6. Negative 3 times negative 6I, so positive 18I. Negative 5I times 2, okay, minus 10I. Negative 5I times negative 6I squared, positive 30I squared. Simplify. Negative 6, 18I minus 10I is equal to plus 8I plus 30, negative 1. Okay, always remember that I squared is equal to negative 1. Okay, then simplify. Negative 36 plus 8I. Negative 36 plus 8I. Okay, first option. Okay, this is the answer. Number 6. Find the modulus of the complex number. Also state the quadrant the point would land in. Modulus. So modulus is okay, distance. Modulus for negative 3 plus I. Okay. In the formulas, you have to substitute the formula and substitute negative 3, 1, or from the given complex number. This is for x value, real part. This is imaginary part. So you get coordinate is negative 3, 1. This is coordinate. Okay, just substitute negative 3 here and 1. Then simplify. 9 plus 1, 10. So modulus is 10. Each quadrant, okay, maybe you can sketch Argand diagram and check. This is coordinate -3, -3 here, -3, 1, -3, 1. So from origin to the line, this is the point. This is the Argand diagram. So it lies in the second quadrant. Modulus 10, second quadrant. So answer is this option. Okay, the second option. Number 7. Express the point in polar form in rectangular form for the given. This is polar form. Okay, you need to express, find the reverse, find this in this form. So 4 cos pi over 3 plus I sin pi over 3. Okay, you can find the value of cos pi over 3. That is half. Okay, and plus 4 here. Okay, I sin pi over 3. You can take sin pi over 3. That is 3 over 2. Then simplify. 4 times half 2 plus 3. 4 times 3 over 2. 2 3 I. So answer is 2 plus 2 3 I. So the answer is the third one, the third option. Number 8. Express the complex number in polar form. Polar form. Z is equal to R cos theta plus I sin theta. This is template for polar form. Okay. So given -2 plus 5i. Maybe you can change to coordinate -2, 5. Okay, this coordinate. So you need to find modulus. This is modulus. Okay, modulus. And this is argument. So first step, find modulus R. Okay, substitute the formula. Substitute. Okay, -2, 5. Okay, substitute. Then the answer is 4 plus 25, 29. So 29. Okay, this is modulus. Next step, you need to find argument. So argument of Z or -2 plus 5i or theta. You need to find argument or theta. So first thing check, this coordinate lies in the second quadrant. Okay, -2, 5. So this is the point. Okay, from origin to the line. Okay, and argument theta, you need to start from positive x-axis to the line. This is theta. Before you find theta, you need to find alpha, basic angle. So you need to find alpha, basic angle. Alpha is equal to tangent. Okay, modulus, that's the value. Here is y, x. So y over x. 5 over -2. Okay, and then, okay, before you use calculator, okay, you need to find the value positive. This is negative value. You need to change to positive. Okay, so 2.5. Okay, you can use calculator. Make sure in radian mode. Your calculator give answer. Alpha is equal to 1.19 radian in radian mode. This is alpha. So to find theta theta is equal to pi minus alpha. Pi, or this one, pi minus alpha. So pi minus 1.19 is equal to, okay, you can use calculator. So it's equal to 1.95 radian. Okay, after that, okay, so your final answer, okay, in polar form, okay, so z is equal to negative 2 plus 5i is equal to, so you can use z is equal to r. R is 29. Okay, you can just use z, z. Okay, z form, because we have to let this one is equal to z. Okay, cos theta is 1.95 radian plus I sin 1.95 radian. So check the option third 29. Cos, so not the answer. Negative, not the option. So answer is the last option. Okay, settle for number 8. For number 9, okay, number 9, change this one to 2. Okay, express the complex number in polar form. Same procedure as number 8. Okay, but the given is 6 plus 2i. Change to coordinate 6, okay, so this is the coordinate. You need to find the, because of the, this you assume this is z, z is equal to something, so polar form is equal to z equals r cos theta plus I sin theta. In that number, the previous number. Okay, so first you need to find modulus of z, or r. Okay, substitute in this formula. Okay, this is 6 and 2, and final answer is 36 plus 4. 36 plus 4 is equal to 40. Okay, 40 or square root of 40 or 2 third 10. Okay, this is modulus. Now you need to find argument of z or theta. Okay, so double check. This is coordinate. Okay, sketch simple Argand diagram. 6. So okay, this point lies in the first quadrant. Okay, so your theta starting from positive x-axis to the line, this is theta, and also alpha. So theta equals alpha. Find alpha, basic angle, to do at tangent x, y over x, 2 over 6, equal to at tangent 1 over 3 in radian mode, and suppose we get the answer is 0.322. This is the answer. Then at the same time, theta, okay, theta is equal to alpha is equal to 0.322 theta. Then you need to find in polar form. Final answer, okay, polar form. So the final answer is z is equal to r is 2 third 10. R is r. Cos theta 0.322 plus I sine 0.322. Okay, and check answer. This is negative. This is 3. Cancel. So answer is the second option, 0.32. Need 2 decimal places, but it's the answer. Okay, that one is for number 9. Okay, the last one is also express the given complex number to polar form. Let's say this is Z. You need to express Z is equal to R modulus cos theta plus I sin theta. Okay, so first step, change to coordinate 3 minus 3. Okay, this is X, real part, this is imaginary part. Okay, so your modulus, or R, substitute in this formula. Okay, 3, negative 3. Then 9 plus 9, 18. Or 3, 2. Okay, so then now the next step is to find argument. So you can sketch simple argument diagram. 3, negative 3. Okay, so the argument diagram is here. Theta, starting from positive x-axis to the line. This is theta. Okay, and this one also alpha. Okay, argument of Z or theta, suppose is equal to negative alpha. Why? Because of theta, this Z lies in the fourth quadrant. Theta, we should get the negative answer. So next, first thing you need to find the C angle alpha. At tangent, okay, y negative 3 over is equal to at tangent 1. Okay, make sure from this one you need to change the positive value before you find at tangent. So answer is pi over 4 in radian mode. Okay, and it implies that argument of Z or theta is equal to negative pi over 4. This is argument. Okay, the first is modulus. Then substitute. Use the template. Z is equal to R. R is 3 2 cos negative pi over 4 plus I sin negative pi over 4. Close the option. Okay, this is not the one. There's no negative for angle. This one. Okay, so answer is 3 2 cos negative pi over 4 plus I sin negative pi over 4. This is the answer.